Okay, so here in this lecture we will discuss binary parallel adder. Binary parallel adder is also known as ripple adder. Binary parallel adder is also known as ripple adder. It is also known as slowest adder. It is also known as slowest adder. Okay. In this binary parallel adder, several full adders are connected parallelly to perform addition process. We know that if data is of 1 bit, so we can add these 3 bits by using one full adder. Okay, but in practical it is not required that the data is always it is not required that it is not essential that the data is always 1 bit. Okay, it means that the data A may be more than 1 bit, the data B may be more than 1 bit. Okay, so at this type of condition, one full adder is not capable to perform whole addition. Okay, so in this time several full adders are connected parallelly. Several full adders are connected parallelly to perform addition process. The number of full adders that is used for this binary parallel addition is depends on the number of bits that is in the register. Suppose here in A register 4 bits are there. In B register these 4 bits are there. So to add this number A and B, we require 4 full adder. How? Suppose our data A equals to A3, A2, A1 and A0, and data B equals to B3, B2, B1 and B0. So at this time, one full adder will add these 2 bits. Second full adder will add these 2 bits. Third full adder will add these 2 bits, and the fourth full adder will add these 2 bits. Okay, but we know that full adder is responsible to add 3 different bits, so that we will consider this starting carry bit as 0. Now after the addition of these 3 bits, when carry is generated, so that carry will propagate here. So the carry that is generated here will propagate here. So at that time this second full adder will get 3 bits automatically. So after the working of second full adder, it will propagate carry towards the third full adder. So third full adder get its third bit and it will works. Okay, we can understand the whole behavior of full adder by using this block diagram. This one is first full adder. I am taking this full adder as F0. If this one is first full adder, so its input bit will be B0 and A0, and accordingly it will provide output as S0. The second full adder is F1, so that its input bit is A1 B1 and its sum bit will be S1. Third full adder is FA2, So its input is A2, B2, and its output is S2. And the last one, FA3. Here the input bits are B3 and A3. Accordingly, we will get sum as S3. Now, in first full adder, the carry bit is always 0. That's why I will represent this carry as grounded. So when it works, it will generate carry and that carry will propagate here. So the carry that is generated is C0. When this first adder will work, so it will generate carry. This carry will ripple towards the second. Okay, this one is C1. When C2 will work, then it will ripple carry towards the FA3. And when it will work, so it will generate carry, that is final carry. So here carry will ripple from one full adder to another full adder. That's why this type of full adder is also known as ripple carry adder. Okay, now if I am considering propagation delay, if I am considering propagation delay, propagation delay is time required. Propagation delay is the time difference between getting the output, providing the input and getting the output. Okay, suppose I am consider that each full adder is having a propagation delay of 50 microsecond. So it means that if this first full adder start working, so it will take 50 microsecond to generate this C0. So when this C0 is provided to FA2, so it will again take 50 microsecond to work. And at last it will again take 50 microsecond to work. So that if our process is started in 0 second, so we will get the final answer after 200 microsecond. Okay, so it means that n into propagation delay TB, n into total propagation delay can be calculated by using n into propagation delay of one full adder. Okay, so here if the propagation delay is considered at 50 microsecond and number of full adder is considered as 4, so total delay of our binary adder will be 200 microsecond total delay. Okay, so that's why we can say if number of bits is increases in the processor, so accordingly the propagation delay will increases. This is the reason why this type of binary parallel adder is known as slowest adder. Okay, thank you so much.